you can see how the estimations are different for the worst case scenario, RCP 8.5, 3.2 to 5.4 degree increase in the global average surface temperature by the end of the century compared to pre-industrial conditions. So that's from the global models. So what do these different temperature worlds and different scenarios mean for Africa? So this is just another slide showing the projected average, the projected increase in the global average surface temperature from a number of A2 scenario simulations. That's the business as usual scenario, going from 1970 to 2100 roughly. These are 11-year moving averages. So I think this is the type of thing that everybody expects. In this case, the temperature increase reaches about 3.5 degrees to 4.5 degrees globally by the end of the century compared to the baseline level. So the first interesting result, for me at least, that I would like to share with you today is this result. This is now one of the models that was integrated globally in the previous slide. There's once again the increase in average temperature. And this is the associated standard deviation. So perhaps this is even the key message of my talk today. So I'll just spend some time in explaining this. For each 11-year period here, the standard deviation was calculated. But before that was done, the 11-year period was detrended. So there's a trend, of course, in each 11-year period because the system is warm. So you remove that trend, and then you calculate the standard deviation. And these are the global averages. This is the global average of the standard deviation over that 130-year period. And one takes care, of course, that the different grid points of the model at the pole where the grids are smaller are counting less compared to the grid points at the equator. And to some extent, the surprising result that this shows is that the system is projected to become less variable. So we often hear that climate change is going to make things less predictable, but actually the system is becoming less predictable, but the system is in fact becoming less variable. And this is a result that is starting to emerge from the most recent papers on climate science. There's just a paper in Nature on this result. And I followed the technique in that paper to arrive at this result from the CSR projections. Unfortunately, I didn't come up with it first. So the key message here is globally variability is decreasing, and the main theory is that it is because of the fact that the sea ice is decreasing. So a system that is tending to be more of an aquaplanet with less sea ice becomes less variable. That's the reigning theory behind that. And this is for the projections. In the recently published paper I've mentioned, this was actually done for observations of the last 5 decades or so. It shows roughly this behavior given for the last 5 decades or so. And these are the next slides are all different simulations of the same thing by different downscalings or different global simulations. And you can see all the 6 models we've considered here are all showing decreases in the global variability or not any significant increases. So it may not be true that the system is going to become less predictable. Of course, that's the global result. If you look at different regions, then it may be different. This is just an output of that standard deviation spatially. For a future period compared to the baseline period, and it is mostly the tropics and the subtropics that are projected to become less variable. And where the westerly waves and the synoptical systems are projected polewards, that's where the system is projected to become more variable. On average, it becomes a less variable system, but if you are living in these high latitude parts, the regional system may well become more variable. So, to arrive at actionable messages for our region, it's important to take note of the temperature signal. That's just a simulation which shows annual average temperature anomalies from 1970 to 2100. Blue is cold, yellow is hot. The top animation is for the RCP 8.5 scenario, and the simulation above is for the RCP 4.5 scenario, the more stronger mitigation scenario. So we are comparing this evolution of our temperature climate for this green line versus the black line there. These are simulations from the LCAS report on projections. So what you can see, there we are now into the future, and what you can see is a strong pattern of regional warming over southern Africa. Exactly in that region that is also projected to become less variable. And this is perhaps a key component of finding actionable messages of change for the Southern African region. We have an extremely strong warming signal over Southern Africa. You can see it compares to the signal over the Sahara to the north. So Southern Africa and the Sahara are warming up much faster than tropical Africa. And that has something to do with the fact that the big subtropical highs are projected to strengthen over this region, shifting the cold front in the westerly wave southwards, making the system less variable, less cloud cover, more sunshine, and a strong surface temperature response. That is qualitatively what's happening within the models if one analyzes the circulation changes. So you can see also how the two emission scenarios lead to a different future. So in the 4.5 scenario, where the global temperature increase is in the order of 2.5 degrees, the regional temperature increase stays just below 4 degrees. And in this case, where the global temperature increase is in the order of 4 degrees or more, the regional response may well reach 8 degrees. So there's a massive potential, a very, very drastic projected change in temperature in a future world where we do not have strong mitigation. And the key message here is that for the Southern African region, temperatures are warming up, projected to warm up at almost twice the global rate of temperature increase. Okay, so I should finish up quickly. If you look at observed trends over the last 5 decades, you can see exactly the same thing. This is already happening. This is from a well-defensible time series data set, which shows that large parts of Southern Africa have experienced warming of more than 2 degrees Celsius per century over the last 5 decades. So this is something that these projected changes is something that we can already observe. We understand the physics, and therefore we have confidence in this message. So I'll just show 2 more slides. This is the second last one. No matter where you look in South Africa, you will, if you do a plot of rainfall anomalies against temperature anomalies, you will see something of this shape. You'll see a present-day future which has quite a broad base of rainfall anomalies. And then as you move from the blue colors, which are present-day, into the mid-future and into the far future, the base of the plot becomes more narrow. As the system becomes less variable, it warms up significantly for Limpopo, almost 7 degrees by the end of the century. So the regional climate system in this case is projected to change from into a state which is much warmer than anything that has been observed in recorded history. So the temperature signal on its own is what we can call an actionable message of change. And these are just results for different parts of the country. I think most of them are in the LCAS report. To conclude, there's evidence that the global system may well become less variable. And here where we live in the subtropics with the stronger highs and more subsidence, there's a fair bit of evidence to think that it's going to become generally drier. There's still uncertainty with respect to that rainfall signal if you compare models, but the temperature signal is something that is extremely robust from one model to the next. So we are in for drastic temperature changes. So it says that we've been involved in a number of applied projects. We are trying to change this into an actionable message, but you can just think, if you are living, say, in the Southwestern Cape, which is much drier is much warmer and probably also drier. One can think, for example, of implications for high fire danger. The maize crop, many credible studies showing large decreases in the maize crop under strong warming. Livestock. By the end of the century, there will probably be no cattle left in the Northern Cape, only springbok. So all that can probably withstand those 6-degree plus temperature increase. And biodiversity, small birds are highly vulnerable to high temperatures. The Fynbos region with changes in fire, for example. So I think there's a fair bit of evidence that we have just from the temperature signal over Southern Africa that we can change into actionable messages for a number of different sectors. I think that's what I'll do.